Remind yourself what the question is. Math is shorthand. There's a whole English sentence behind this. What does it take 4 of to multiply to be 16? That is the English sentence behind that. As a math person, I don't want to write all that shit. I want to write shorthand for that, tell everybody what it means, and then we can all just do it, get to the answer, and keep going. I got Game of Thrones to catch up on. So yes, this is 2 because it takes 4 2s to multiply to be 16. That's why, just the same way that this is 9, because the understood 2 here tells me that it takes 2 9s to make 81. Kick ass. So what about this here?
Imaginary number.
It's a little worse than imaginary, to be honest. It is imaginary, but it's kind of really, really gross. Well, let's not do that. We don't know imaginary officially, so we're not even going to go that route.
Complex.
Is there a real answer?
No.
So then you can say not real, or no real answer. That's all I have to worry about right now. The minute we get to talking about complex numbers, then you'll have to actually give me the complex answer. But for right now, notice, now real quick, on the heels of this, is everybody cool with this? Because there is no number you can multiply by itself 4 times and get negative 16. If they're negative, all the negatives cancel. If they're positive, there were no negatives to begin with. There's no way to make negative 16 out of 4 of the same real number. Is everybody cool with that? Mm-hmm. Okay. If you don't believe me, try it. You just can't do it. But on the heels of that, what's the cube root of negative 64?
Negative 40.
Negative 4. All day long. Because now there's 3 of them. If they're negative, 2 of the negatives cancel, and it's still negative. So odd roots can handle negatives all day. Because if I have an odd number of negatives, it's still negative at the end. You guys kind of with me? So if I cube a negative number, it stays negative. If I cube a positive number, it stays positive. But if I take a negative number to the 4th power, it becomes positive. Do you guys see what I'm saying? That's why a 4th root can't handle negatives, because a 4th root's kind of trying to undo a 4th power. And the 4th power's always got to come out positive for real numbers. I don't know if you guys see what I'm saying. So odd roots, very laid back. You're negative? Okay, the answer's negative, no good. Even roots, they're not so relaxed. They're a little uptight. They can only handle positive inputs. So this is negative 4, because negative 4 times negative 4 is 16, times negative 4 is negative 64. So don't say not real if the root is odd. What about this here? Yeah. So far I've given you smaller numbers that are familiar to us from doing our cubes. We should know 64 breaks up into 4s from our cube difference in some of the cubes work. But that, I just kind of gave it away. If you hit a number you're not sure about, you start to try to break it up. 343 is a really ugly number. Poor little number. Good. So if you try to start, you can't divide it by any even number. Obviously, not even. So then you divide it by 3. No good. 5. Obviously not. 7 goes in. 7 times 49. And what's 49?
7 times 7.
So what does it take 3 of to multiply by 343?
7.
So that's the answer. So if you hit a number you're not sure about, just start breaking it up. Start breaking it up. Is that cool so far? I mean, considering that roots are trying to say, what does it take this many of to make this number? Well, if you break a number down into its parts, you can see what goes into making it. And that'll help you answer the question. Guys, all right.
Oh, yeah.
Can't read most of you at all. All right, script. I'm going to assume it's going good.
Just remind me, the last 2 digits, if they are had to be 7. So
No. 7 has no rule.
Okay.
7 is the only number without a rule.
Only 3 and 1?
If the last 2 numbers are divisible by 4, then the whole number is divisible by 4. All right, I've told you a few of these things, right? You know about even numbers and how they work. How do I know if 3 goes into a number?
added negative.
If all the numbers, 8 plus 1 is 9, 9 is divisible by 3, so 81 is divisible by 3. Yes?
Where do you get 49?
343 divided by 7?
Where do you get 7?
Just guessing. So 343, I can't divide it by 2. I just try to divide it by 3, that doesn't work. Try to divide it by 5, that doesn't work. Try to divide it by 7, that works. That's how you break up a number, isn't it? We've factored numbers. How do you break it up if you're not sure? You just start trying stuff until you get something that actually goes in. We know this. We know how to break numbers up. You're going to have a calculator with you. That'll make it a little bit easier. Right? Don't just tell me the answer is 7 because you know how to get your cube root button. I need to see some freaking work so that I know you didn't just go to your cube root button. All right, maybe. So your calculator can help you by dividing all day long. Is that cool? Yes, okay. Sure, you guys try this one. Oh, that would be really gross, Jeff. All right. So just do this. Does that work? Yeah. Yeah, if you start to, obviously you can't divide it by 2. You can't divide it by 3 because it doesn't add to a multiple of 3. You can't divide it by 5 because the last number is not a 5 or 0.
31 times.
Sorry?
31 is prime. Isn't 31 prime?
31's prime, total. But 1331 is not prime.
Yes.
Yeah. Where did it leave off?
Well, what I mean is 0 to 10 is out of it.
Exactly. Yeah, good point. So I can throw out 2 and 4 and 6. I can throw out all evens. I can throw out 5 and 10 and all those. I try 7. 7 doesn't work. And then the next number to try is 11. That's the only one left. Do you guys see what's happening? So I'm thinking 1 through 10 to begin with, and nothing in there works. So then the next thing you try is 11. And sure enough, it's 11 times 121. And what's 121? 11 times 11. 11. I like it. Cool. Real quick word about 11. This is going to seem completely unrelated. But you guys have you ever seen this?
Yeah.
Some of you guys have, but see how the outside's just ones? 1 plus 1 is 2. And put ones on the outside. So what's going to be next? The 1 on the outside. 1 plus 2 is 3. 2 plus 1 is 3. Put a 1 on the outside. What's 11 times 11?
21.
What's 11 times 1?
11.
What's 11 times 11 times 11?
1, 3, 3, 1.
And what's 11 times 11 times 11 times 11?
1, 4, 6, 4, 1.
Neat. That's not the only thing this thing does, by the way. All right. Go with me. I'm going off on a tangent, and I don't care. This has nothing to do with this section, nothing to do with the semester even. But I don't seem to care. I keep doing it. What's x plus 1 squared?
X plus 1. That's X plus
Good. And then when you do that, what do you get?
X squared plus 1.
X squared plus 1x plus 1x, so plus 2x plus 1. What are the coefficients?
1, 0,
X plus 1 cubed would become x squared plus 3x, got it, squared, cubed, 3x squared plus 3x plus 1. If you did that all the way out, you would get this, 1, 3, 3, 1, holy shit. X plus 1 to the fourth would be 1x to the fourth plus 4x cubed plus 6x squared plus 4x plus 1. Neat. And you're all like, whatever. But still, it's neat. This is called Pascal's triangle. Later, you'll use it to develop a shortcut for doing anything like this. Just want to throw it out there since it kind of came up with the numbers. All right.
Is that Pascal or Pascal?
Pascal. So this is Pascal's triangle. Pascal's triangle. is related to the binomial theorem. Binomial expansion is also called. But again, nothing to do with this class. Okay. Let's see, where else we go? Alright, here we go. Ready? So here's where things get interesting. What's the square root of, it's going to seem silly. What's the square root of 5 squared? No. What's the square root of 5 squared? 5. So what's the square root and the square seem to do to each other? Cancel somehow, right? In some way. But 5 squared is 25, and the square root of 25 is 5. Now, what's the square root of negative 3 squared? No. 3. Because what's negative 3 squared? What is negative 3 squared? 9. So, this kind of comes from and is related to this idea. How many answers are there to this question? There are 2 answers. What are they? 3 and negative 3. So when I see this symbol, when I see this, it is asking me for one of those. It is asking me for the positive one of those. That's why the square root of 9 is 3. So how do I get the negative one? Well, I have to say specifically, I want the negative root of 9, and so that would be negative 3. So when you see the symbol, square root symbol, it specifically means the positive answer. The positive number that I squared to get this thing. So that's another reason why this had to come out to be positive 3, because it's asking you for the positive root. Yeah, I like it. Maybe. Maybe not. No poker. I'm never. You invite me to a poker game with you guys, I'm not playing. I'm not. I don't have enough money for that. Alright, so what about, you ready? No. What did I...
Negative and positive.
No. Good try. What's the square root of 5 squared? 5. What's the square root of negative 5 squared? 5. So the answer to a square root has to always come out to be positive. Isn't that what I just said here? Right? It's the positive answer. What other function makes everything positive? There's a function that makes everything positive. Absolute value. Whoever said that over there. So this is not equal to x. I can't just kill the square. The square root of x squared is equal to absolute value. So now, looking back, this makes a little more sense. These two sort of cancel, but the answer is the absolute value of negative 3, which is 3. And maybe. So it's different. This is not the same thing as saying the square root of x squared equals plus or minus x. That is different from this. This says the square root of x squared has to come out to be positive. That's the only answer I'm going to accept. It's the positive answer. This is saying there are 2 answers and one of them is negative. You see the difference there? Be careful. Anytime I got to force the answer to be positive, I can use the absolute value to do that. If you take statistics, we do that in a few places in stats. Maybe. If you don't, we still do it a few places in stats. You're just not going to see it. Okay. What other weirdness is there? Oh, all right. Let's do this. So some of you guys already know what a square root looks like graphically. If you, yes. If you don't just reach for your calculator. If you ever learn, see a function, you're not sure what it looks like, what do you do to see what it looks like? What do you make to see what it looks like graphically? What do you make?
You draw a table.
Table, right? XY table, because you can collect a lot of points and connect them. Cool? All right. So when I make an XY table here, what's the smallest number I can use?
0.
Good, because I can't take a square root of a negative number. I don't want to go there yet. A square root of 0 is definitely 0, because it's asking what times itself is 0? 0.
4, 2.
Let's go with something in between. What's the next good number to use?
1.
1. Square root of 1. 1. Now, if you stop there, you're going to think it's a straight line. Well, it can't be a straight line because is this linear? No, it's not.
Like that.
Yes, it is. And so the next good, do I want to use 2?
No.
No. Do I want to use 3? No. I want to use 4 because square root of 4 is 2. The next good number would be 9 because square root of 9 is 3. I like it. Okay, how are we doing so far? Anytime, because in pre-calculus, holy shit, you're going to learn functions and new functions and new functions and new functions, and the first thing you do is you make an XY table so you can tell what the hell it looks like. In this class, we still have several functions ahead of us to learn, and we're going to make an XY table to see what the hell it looks like. So what the hell does it look like? Well, let's see. It starts at 0, 0. By the way, I really want to make a big deal out of this, because when I teach pre-calculus, I want to go slap some of my 110 compatriots if they didn't make a big enough deal about this. Pre-calculus is graphing hell, just to tell you directly. It's supposed to be so that when you get to calculus, the graphs are not the problem, the calculus is the problem. So pre-calculus is supposed to make you just do all this different graphical stuff. So I'm sorry if you hate graphics, just do that. But when you make graphs, good Lord, this is not acceptable graph of a line. Some of you guys are like, that's a line, Jeff. But what's wrong with that? There's no points. There's no scale. There's no nothing. Holy shit. No. So bad. I need scale. Right? I need consistent scale as best you can. If you have trouble with that like me, then get some graph paper. You can print it out from online for free, except for the cost of ink and paper. Or just buy a thing of graph paper. Dear God, please. Right? So 0, 0, 1, 1, 4, 2, and 9, 3. So it looks like this. Woo-hoo! Make that big, make that big. So it looks like part of a parabola, which makes some sense because the square root is the opposite of square, which is what a parabola would be. Why is it not down here? Because it doesn't include the negative answers. Okay, maybe. Plus, if it was down here too, would it be a function? It would not pass the. Oh shit! So that's another reason why we defined it to be this way. I like it. Maybe. So that's what it looks like graphically. So you might have to graph a few radical functions, and you just make an XY table if you want to. But basically, if I said in the air, make a square roots function, you just go like that. From your perspective, it would be like that. From my perspective, it would be like that. Okay. Let's see if there's anything else freaky in here. Can somebody give me a guess? So don't use a calculator. Give me a guess as to what this is here.
7 something.
7. 3. 7.
Yeah, 7 point something rather, right? Because 52 is in between what two good numbers for square roots?
49.
And 64. This is not me breaking it up, by the way. It's between these two numbers, right? So the square root's going to be between 7 and 8, probably closer to 7. So maybe 7.1 or something. Somebody do it for me in the calculator. What is the square root of 52? Do it again.
7.21.
So square root of 52 is 7.21. Cool. Alright. Does everybody know how to use the square root button in the calculator? Do you have a calculator? Everybody know how to use that bad boy? Yes? Okay. Good. You're good. Okay. I think that's it for 10-1. Let's do a little bit more and then we'll take a break. trying to work my way up to this group work thing I have for you guys. So remarkably enough, we'll do a little bit out of 10 too, just to keep this in order thing going. Now remember what I said, like square root of 64, you should know from when we did cubes, right? Difference in sum of cubes. And squares. So the cube root of 64 and the square root of 64 are interesting. What's the cube root of 64? 4. What's the square root of 64? 8. So square roots cut things in half, multiplicatively. I love it. Cube roots cut things in thirds, multiplicatively. I like it, right? So I wouldn't say that the square root of 64 is 32. It doesn't cut it in half additively. It cuts it in half multiplicatively. Are you guys cool with that? You probably have to be, because I've said that kind of thing before. Okay. So what's my point? Oh God, if I just had one. So tell me, what position on a number deals with keeping track of multiplication? That's a weird statement. Let me just give you the answer because it's kind of weird. Exponents keep track of multiplications, right? So this wants to take 7 and double it multiplicatively, doesn't it? Not just 1 7, but it wants 2 7s all of a sudden, right? So a square root does the opposite of this. So it doesn't want a full 9, it wants half of 9. Or it doesn't want a full 64, it wants half. You can do it, Jeff. Half of 64 multiplicatively. Oh shit. Are you guys... I just can't read. Some of you guys are like, I know that shit. And some of you guys are probably, oh, I know this shit. I'm just going to sit here. So how would I rewrite the cube root of 64? 64 to the 1/3. I like it. So fifth root would be a 1/5 power, so forth. Maybe? No? I like the looks I'm getting right now. So just like, if I wanted to cut 64 and tell me it's 32 plus 32, if I wanted to use it to make it 32, I'll put the 1/2 there, right? Because that deals with addition. What's 2x mean? X plus x. So coefficient deals with addition. So if I wanted half of something additively, I would put it in the coefficient. If I want half of something multiplicatively, I'm going to put it in the freaking exponent. Okay, maybe. This is something that Mac 90 people we didn't talk about. I don't think. I can't remember. Yes, maybe we did.
I know if you're going to do 1/2 about 0.5.
Sure. Anything that means 1/2 would give you the same answer. I like it. But it's better to write it as a fraction because then you can see what the root is. See? So if I go in the other way. So that would be that. Multiplicatively would do that. So, what was I just thinking about?
1/2 squared.
7 to the 1/5.
Let's do the 5th root.
How would I rewrite that?
You rewrite that as 7 to the 5th power, or it says 5th root of 7.
There it is, 5th root of 7. Cool, I like it.
I stumbled a little bit.
I understand. Alright, now keep going with me. Does everybody kind of get that basic idea? Radicals can also be written as fractional powers, because they do cut things down multiplicatively. In fact, I kind of wish I existed way back when. There's no reason we should have even used radical notation, to be completely honest. That's the one we're more used to. But once you start doing this, you're like, why does this even exist? It didn't have to exist. It just sort of both developed, and they were like, we're going to keep doing both. Nah, whatever. I'm okay with it. Alright, now watch this. So if I see the square root of 64, I can write that as 64 to the 1/2. I really want you guys to fully buy into this. I'm going to do, as so often happens, and some of you guys don't understand why I do this. I'm going to do something you're never going to do, but it explains why things happen. How can I write 64 something squared? What's squared is 64? 8. What do I do with powers when they're like this? Well, what do I do with the powers when I multiply them? In this case, they're going to cancel. 2 times 1/2 is And sure enough, the square root of 64 is 8. I am not saying that this is a great way to do this. You're like, I knew the square root of 64 is 8, Jeff. What's that shit all about? This shit is further explaining why that makes sense. Just a little different way to look at it. Maybe. Maybe not. Okay. So what if I had... How do I explain this? Let me see. So what if I had square root of 9? So that's 3 squared to the 1/2 power, right? What? Mm-hmm. So, and that would be 3. So what if I had square root of 81? That's 3 to the what power?
3.
How many 3's does it take to make 81? 4. All right, let me stop there for a second and make sure everybody's with me. I rewrote 81 as 3 to the 4th, and I rewrote square root as a 1/2 power. Now watch, I'm going to do something kind of silly, and I don't care. Isn't that 3 to the 4 over 2?
Yeah.
I like it. Yes, Jeff, sure. So now watch. Now I'm going to do... Now again, I'm not going to get the answer. I'm trying to explain why rewriting things a certain way makes sense. What's the root? Second root. Because that number's on the bottom. And what's on the bottom of most plants? Roots. I love it. So whenever I have a fractional power, the bottom is the root. Because that's where roots are. Now, botanists shut up about potatoes and all that kind of crap. Some roots are... No, most roots are underneath, or under. And the top, so I can say this is the square root of 3 to the 4th power. That means the same thing. Is that nicer to look at than this? No. But they mean the same thing. I don't know if you guys know with me. This is 3 to the 1/2 to the 4th. So these mean the same thing. I can change these around. I can put the 4 on the outside, or I can put the 4 on the inside and make it 81. All right, let me bring this back down. Let me make this a little more practical. So here's what I'm trying to get you guys to realize. If I had this 8 to the 2/3 power, how can I rewrite that to start attacking it? What's the root? Cube root of 8. And I could put the 2 on the inside, or I could put the 2 on the outside. Doesn't matter, because it ends at 1/3 times 2 is the same thing as 2 times 1/3. It doesn't matter where you put the 2 and the 1/3. It does not matter. Cube root of 8 is 2. Squared is 4. Okay. This is how you break down a number that's raised to a fractional power. Now a slightly different way to look at this. Break 8 up into 3 parts. What would it be? 2, 2, 2. And how many of those do I want? 2 of them. So I get 4. That's the answer. 2/3 of 8 multiplicatively is 4. It's a whole other way to look at it. Do you have to be able to look at it that way? No. Pick a way that makes sense and do that. Let's keep going. Oh shit. So what about this here? 27 to the negative 4/3 power. You knew I had to bring negatives in sometime. That's the first thing I'm going to worry about. The mistake people make. This is a mistake. Don't even write this down. The mistake people make is they write this. So if you were thinking about doing that, don't ever do that. Is the 4/3 being raised to a negative power? So why would it flip? 4/3 is the negative power. What's being raised to a negative power? 27. So this becomes 1 over 27 to the 4/3. Like always. X to the negative 2 is 1 over x squared. The negative makes it flip and the other number's still there. It still has to be done. Don't flip the power itself. That's crazy. Negative 4/3 does not equal 3/4. That's a neat statement to make. I owe you money. No, actually, you owe me money. See, haha. No, it's not going to work. Is everybody cool with that first step? No, yes? Because what's 8 to the negative 2? What's the first step I could do?
1 over 8 squared.
1 over 8 squared. What's 7 to the negative 5th? 1 over 7 to the 5th. What's 6 to the negative m?
1 over 6.
1 over 6 to the m. So 27 to the negative who cares is 1 over 27 to the who cares. Bam! It doesn't matter if it's a fraction. It doesn't matter if it's a letter. So the negative makes it flip. And now I can focus on this. How do I rewrite that? What's the root?
The cube.
Cube root. 27. Now you could put the 4 on the inside, and then you have to do 27 times 27 times 27 times 27. Screw that. I'm going to put the 4 on the outside. Does everybody understand why you can do that? Does anybody care?
Because you're
I don't know if you guys-
eventually
Yes.
to the 4th power, whatever happens in that root system.
I love it. So the cube root is the 1/3, and the 4th power is the times 4. Who cares which order I do it in? They're both 4/3. So that's why I can have the 4 on the inside or the outside. I put it on the outside when I have an actual freaking number. So I get less shit to do. Right? What is the cube root of 27? 3. What's 3 to the 4th?
81.
Sweet. Maybe. You guys must take a class on that. Right? No, I can still see emotion in your face.